Welcome to this episode of Easy Physics. Today, we are going to delve into the intriguing world of Ant-Man and uncover the physics behind this incredible superhero. Ant-Man, a Marvel character, possesses the ability to shrink down to the size of an ant while maintaining his original strength. This concept may seem like pure science fiction, but let's explore the underlying physics principles that could make it possible. To understand the physics behind Ant-Man, we need to explore two fundamental concepts: size manipulation and the conservation of mass. Size manipulation involves changing the scale or size of an object or individual. In the case of Ant-Man, he can shrink down to the size of an ant while retaining his normal strength. To achieve this effect, we can look at the concept of scale-dependent properties. When an object is scaled down, its surface area decreases while its volume decreases at a faster rate. This means that the ratio of surface area to volume increases as the size decreases. In simpler terms, when Ant-Man shrinks, his body's surface area decreases, which reduces the forces acting on him. Consequently, he can withstand greater forces relative to his size, making him appear stronger. The conservation of mass is another fundamental principle to consider. According to this principle, the total mass of a closed system remains constant, regardless of any physical or chemical changes that occur within the system. In the world of Ant-Man, despite shrinking in size, he retains the same mass, allowing him to maintain his strength. To explain this, we can refer to the concept of atomic and subatomic scales. At these scales, the mass of an object is primarily determined by the particles it contains, such as protons, neutrons, and electrons. When Ant-Man shrinks, the number of particles within his body remains constant, resulting in the preservation of his mass. However, it's important to note that the physics behind Ant-Man's size manipulation and conservation of mass are still largely speculative. While we have discussed some plausible explanations based on scientific principles, the actual mechanisms behind these abilities are purely fictional and not yet understood by modern science. In the Marvel universe, Ant-Man's size manipulation is attributed to a fictional substance known as the Pym particles. These particles are said to alter the distance between atoms without changing their mass, enabling Ant-Man to shrink or grow at will. While this concept is not grounded in real-world physics, it serves as a fascinating element in the superhero's story. It's worth mentioning that the quantum realm is often associated with Ant-Man's abilities. The quantum realm is a hypothetical realm of reality where the laws of classical physics break down and quantum mechanics dominate. In this realm, particles can exhibit strange behaviors, such as superposition and entanglement. While the quantum realm is a topic of active research in physics, it is still a theoretical concept, and its connection to Ant-Man's abilities remains purely fictional. In summary, the physics behind Ant-Man's size manipulation and conservation of mass are intriguing concepts that blend science and fiction. While we can explore scale-dependent properties and the conservation of mass to provide some insights into his abilities, it's essential to recognize the fictional nature of these concepts. Ant-Man's powers, as depicted in the Marvel universe, are a product of imagination and storytelling rather than current scientific understanding.